Hello everyone, I am Supratim, your coach from Techmine Guru. Welcome to today's Path to Mystery. This session isn't just about writing code, it is about a complete mindset shift. We are going to navigate through the brute force trap, unlocking the mathematical power of the contribution technique, and finally mastering the sliding window problem. So why are these techniques so critical? Because as we say here, we are moving from iterating loops to calculating impact. We need to stop looking at data the hard way and start seeing the patterns underneath. So let's begin. Given an array, find the total sum of all subarrays. So we have 3, 2, 5 as an array. So how many arrays will start with index 0, 3, 3, 2, 3, 2, 5? So this sum will be 3, 3 plus 2 will be 5, and 3 plus 2 plus 5 will be 10. Similarly, how many subarrays will start from the index 2, 2 and 2 comma 5? So this will give the sum 2, this will give 2 plus 5, 7, last will be 5, right? So the total sum of all possible subarrays will be 3 plus 5 plus 10 plus 2 plus 7 plus 5, which will come out 32. Similarly, if we see for the example of 1, 3, 2, 5, so how many arrays will start with the index 0? 1, 1 comma 3, 1 comma 3 comma 2, 1 comma 3 comma 2 comma 5. So this will give 1, this will give 4, this will give 1 plus 3 plus 2, 6, this will give 11. Similarly, how many subarrays which will start from the index 3, 3, 3 plus 2, 5, 3 plus 2 plus 5, 10. And similarly, we will get for 2, 2, 2 comma 5, and for 5, there is one subarray. After adding all these numbers, we will get the total sum as 54, right? So what is the brute force approach? So just as we learned in our previous class that how to find the total number of subarrays, we will use the same thing. So we will run a loop for I is equal to 0 to n minus 1, which will tell start indices of the subarray. Then the second loop for j is equal to I to n minus 1, which will tell you the end indices of the subarray. And once we have the subarray of size I comma j, we iterate the subarray from k is equal to I to j. So we have to keep adding the sum of that particular subarray inside this sum variable, right? And once this will give the sum of that subarray, we will take one more variable as answer, and we will keep adding the sum into that answer variable so that we get the cumulative sum of all the subarrays. So if you see, there are 3 loops here for start index, one for end index, and one in which we are iterating over the subarray. So what will be the time complexity? O of n cube, right? And what is the space complexity? Since we are not taking any extra space, the space complexity will be O of 1 only. So if in the question, if n is equal to 10 to the power 5 is given as a constant, then definitely TLE would come, because 10 to the power 15 is much greater than 10 to the power 8, right? So we have to find a better way to solve this. So can we solve this by something which we have learned earlier, like prefix sum? Definitely. So I have not written the code for creating a prefix sum, that you can already refer from prefix sum array lecture. So in this, just we are iterating over the start index and the end indices, and the third loop we are completely removing. Why? Because instead of that third loop, we are calculating that by using the formula PF of R minus PF of L minus 1, where R is the right indices and L is the left indices. So in this, the code will look as if I is equal to 0. So what is I? I is something which is telling about the start indices, and start is something which is coming into the left, right? So this is for left and this is for right. So if left is 0, we don't have any left element. So sum will be equal to PF of j. And when left we have something, that time sum will be equal to PF of j minus PF of I minus 1, which is similar to PF of R minus PF of L minus 1. So now we are reducing the complexity from O of n cube to n square. But still, if we are given the constant as 10 to the power 5, our code will not work, because this code will work for till 10 to the power 4. And This previous code will work only till 10 to the power 2, right? So there is slight one another technique which we called as carry forward, in which we don't have to calculate the prefix sum as well. So let's understand that one as well. So what is prefix sum? So if we have given the array -4, 1, 3, 2, so we will keep two variables, sum and the answer. This sum will tell the current subarray sum and the answer will be the cumulative sum of all the subarrays. So let's go through it one by one. When I is equal to 0, we have j is equal to 0. So if j is equal to 0, sum will be sum plus a of 0. So sum will be equal to -4 and answer will be answer plus sum, right? Now in answer variable, initially it was 0. So 0 plus -4, which will give you -4. Similarly, when we will move to j is equal to 1, in the sum, we already have -4 plus 1, which will give as a current sum as -3. And when we will add that current subarray sum to our answer array, so -4 plus -3 will give you -7. Similarly, for j is equal to 2, we will get -7 again, because till j is equal to 1, we got sum is equal to -3. So -3 plus 3 will give the current subarray sum as 0. And then adding up to that answer, the current sum will not make any effect. So the answer will be -7 only. Similarly, for j is equal to 3, we will add third element into our current sum. Our current sum was 0. We are adding this 2 into that. The sum will be 2. And in the answer, when we are adding -7 plus 2, we are getting answer is equal to -5, right? Similarly, for I is equal to 1 also, we will follow the same process. So in this, basically, we are removing the inner loop by carrying the sum forward. That's why the name suggests as the carry forward, where it means sum of subarray from I comma j is equal to sum of elements from I to j minus 1 plus that element a of j. So in each step, we are adding the sum to our answer variable. So in this loop is for the start indices, this loop is for the end indices, and every time we are adding every element into the sum, and we are adding up that sum into our answer variable to get the cumulative sum of all the subarrays. So this technique is called carry forward technique. So this technique, since we are running inside two loops, so this technique will also give us O(n) square time complexity, and since we are not taking any other extra space, it will give us space complexity as O of. Now we can do much better than this. So the final technique which we are going to see will be the contribution technique. Okay, before understanding contribution technique, let's see the example of this array, and let's see how many times each element appears in all subarrays. So if you see 1 will appear in how many subarrays? 1, 1, 3, 1, 3, 2, and 1, 3, 2, and 5, right? So 4 subarrays. Similarly, if you see 3 is coming already in these 3 subarrays, and along with that 3 will come in 3, 2 subarray also. 3 will come in 3, 2, 5 subarray also, right? And 3 will come alone as well. So here also 3 will be there. Here also 3 is there in this subarray. In this one also it is there. And this is the new subarrays which are getting created by the other indices also. Similarly, if you see for 2 will also come in 6 subarrays. And 5, again, 5 is coming in this subarray. 5 is coming in this subarray. 5 will come in this subarray as well. 2, 5 also. And 5 will come in the only element subarray as well. So finally, we will get 1 is present in 4 subarrays, 3 is present in 6 subarrays, 2 is present in 6 subarrays, and 5 is present in 4 subarrays. So what will be the answer? Answer will be 1 into 4 plus 3 into 6 plus 2 into 6 plus 5 into 4, which will give the answer as 54. So what we have seen here, right? 54 was coming when we were calculating it. So if I ask you, in how many subarray is index I present? If I ask you if how many subarrays index 1 is present. So index 1 will be present in 0 to 1 subarray. 0 to 2 subarray, 0 to 1 means this subarray, this subarray, this subarray, this subarray, and this subarray. Similarly, this subarray, this subarray, this subarray, and this subarray. So 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, and 1, 1, 1, 2, 1, 3, 1, 4, and 1, 5. So total number of subarrays in which index 1 is present will be 10 subarrays, right? Similarly, if we see for index 2, in how many subarrays it will be present? So from 0 to 2, it will be present. From 0 to 3, it will be present. From 0 to 4, it will be present. And from 0 to 5, it will be present. Similarly, if we start from 1, then 1 to 2, it will be present. 1 to 3, it will be present. 1 to 4, it will be present. And 1 to 5, it will be present. And similarly, if we start from that index only, it will be present in only that element, 2 to 3, 2 to 4, and 2 to 5, right? So how many total subarrays will be there for checking index 2 is present or not? 12 subarrays. So did you find any pattern? The pattern is, if we want to know that index 2 is present in how many subarrays, then we can clearly see the start indices will be 0, 1, and 2, right? And the end indices will be 2, 3, 4, and 5. So if we multiply both of them, we will get 3 into 4 as 12, right? Now let's generalize this number of subarrays where ith index is present. So if you want to know this ith element is present in how many subarrays, then what are the possible number of choices we get for the start index? It will be 0, 1, 2, 3, up to I. That means there will be I plus 1 choices, right? Similarly, if we want to know that how many n indices should be there to include ith element in their subarray, will be I itself, I plus 1, I plus 2, till n minus end of the array. That means I to n minus 1, which means n minus 1 minus I plus 1, right? So minus 1 will cancel each other, then n minus 1 choices. In this way, we have generalized that if we are given n elements, then number of subarrays where ith index will be present will be I plus 1 for the start indices and n minus I for the n indices. So from here, we are getting a formula that number of subarrays in which ith index is present is I plus 1 into n minus 1. And after that, we just need to multiply the element present in that index, and we will be able to understand the contribution of that element in the array. And if we do a summation of this, we will get every element's contribution in the subarray, and in turn, we will get the sum of total number of subarrays. Let's see whether the above formula is working with our example or not. We have an array A of n, which is equal to 6, 8, minus 1, and 7, where n is equal to 4. So for I is equal to 0, if we apply this formula, then 0 plus 1 will be 1, and n minus I, since I is 0, 4 minus 0, 1 into 4, 4. Similarly, for I is equal to 1, 1 plus 1 into 4 minus 1, which is equal to 2 into 3, 6. I is equal to 2, 2 plus 1 into 4 minus 2, which is equal to 3 into 2, again 6. And when I is equal to 3, 3 plus 1 into 4 minus I, which is 4 minus 3, which is equal to 4 into 1, 4, right? So if we want to find the contribution of 6 in number of subarrays, it will be 6 into 4, 24. Second element 8. How many contributions are there? 6. 8 into 6, 48. Third element minus 1. How many contributions are there? 6. 1 into minus 6, minus 6. And again, fourth element as 7. Number of contribution for the 7 in subarrays will be 4. 7 into 4, 28. So if we add up all this, we will get the answer as 94, right? So let's see the solution of this. The solution, we don't have to do anything. We just need to put up this formula and multiply with the element. Just we need to do the summation by iterating over the array. Since you can see we are iterating over one for loop only, So the number of iterations will be n and time complexity will be O of n. And since we are not taking any extra space, the space complexity will be O of 1. Now let's move on to the second part of our lecture. So suppose we have given an array and we have to print maximum subarray sum for all subarrays with length is equal to k. So we have been given two things. Suppose n is equal to 10 is given and k is equal to 5. We have the length of the subarray window as 5 and we need to see that how many 5 length subarrays are there, in that which one is giving the maximum subarray sum, right? So let's understand that with a brute force approach. So if start index we have defined as 0 and end index we know that it is 5 only, so we can do I is equal to 0 to j k minus 1, right? And we will keep shifting k to 1 1 left. So first initially we will be here, in the second iteration we will be here, in the third iteration we will be here, in fourth iteration we will be here. Similarly, we will reach the end of the array. So that's why j will run till j is less than n, and since we are starting j from k minus 1, so j will run an iteration from k minus 1 to n minus 1, right? So if we have this one, then using our previous formula, which we know, n minus 1 minus k plus 1 minus 1, right? So this minus 1 will cancel each other and we will get n minus k plus 1 iteration. Now we need one more loop which will run from ith index till that jth index, and it will keep calculating the sum here. And at last, when we will have the sum, we will just call a max function which will tell whether our previous answer is greater than the current sum or not, and it will give you the current answer value. And similarly, we have to iterate I plus plus and j plus plus. So if you see, we are running two loops here. One for the j, which will run for n minus k plus 1 iterations, and one for p, which will run from I to j, which will be again k iterations only, because k times only we will move forward, right? So what will be the total iterations? N minus k plus 1 into k. N minus k plus 1 is the outer iteration and inner iteration will be k. So total iterations will be n minus k plus 1 into k, which is again time complexity will be O(n) square. So we need to optimize it by seeing one pattern over here. So what is the optimization? So the optimization here is using sliding window concept. So the sliding window is again a type of carry forward only, where we will carry the previous sum which we have got from the previous iteration, right? So if we see this array, this is the long array and we have k is equal to 5. So initially this will be our sub array, right? Then sum will be minus 3 plus 1 minus 2 plus 5 0, which will come as 1, right? Now if we have to slide the sub array, then when we are sliding the sub array, if you see a pattern, we are removing a of 0 and we are adding. So if we see, when we slide the sub array by one window, we will see that we are removing the first element and we are adding up the 1 in the array, right? So our previous sum will be 1, right? And we are removing minus 3. So minus of minus 3 will be 3 and plus 1, which will give us the new subarray sum as 5. Similarly, when j is equal to 6, at that time we will move from here to here. That time we will remove from the window a of 1 and we will add the sixth element in the array, which is 2 in this case, right? So our previous sum was 5. We are removing 1 from the array and we are adding 2 into the array, which will give us 6 as the answer. So basically, you just have to remember that the new sum will always be equal to old sum minus leaving element plus entering element. So new sum will be old sum minus a of I minus 1 plus a of j. Since I is telling you about the previous start index and j is telling you about the end index. So in this code, we have broken the iterations. In this, we are trying to calculate only all the element sum for the first window. So if we have to calculate the first window sum, we will do for I is equal to 0 to k minus 1, since k will be given as the window size. So we will sum up all the elements till that k index, and we will keep the value in the answer array. And now for the next window, since I will tell that in which window we are, so we have already covered the first window. Now we will move from second window till kth window. So we will take I is equal to 1, and since our n index have already covered till k minus 1, so j will start from k, right? And j will move till n minus k, because k it has already covered. Now it has to go till n minus 1, then it will be n minus k iterations, right? So in the sum, if you see, we are removing the previous element and we are adding the new element, and just we are iterating the start index and the end index. And in this, again, we are checking the maximum between the previous answer and the sum variable, and which will give you the current answer. This will finally give you the maximum kth subarray sum from our array. So you have seen that for printing maximum subarray with length k, we came from brute force approach, which was O(n) square to O of n. And since we are not taking any extra space or any extra array, so the space complexity remains the same, which is O of 1. So now let's understand that when to use what. So you will use contribution technique when your goal is to sum up all possible subarrays, and you just have to remember this formula, and you now know how this formula comes up. And when the goal is to find subarrays of fixed length k, that time you will use the sliding window approach, where you will see that if in the elements we have to add entering element, we have to remove, we are sliding from one part to another, like that kind of questions, where you will use the sliding window approach. And if you see, both techniques avoid nested loops to achieve O(n) efficiency, right? So let's summarize everything what we have learned till now. So sum of all subarrays in brute force gives us O(n) cube solution, which we tried to fix it via prefix sum and carry forward, which was again O(n) square, right? After that, we learned contribution technique, which reduced that problem from O(n) square to O of n. Similarly, for fixed length maximum sum question, we started with the brute force approach, which was again O of n into k, which is again O(n) square. And then by just seeing a pattern and using the sliding window effectively, we have reduced that O(n) square to O of n. So congratulations, guys. You have effectively mastered linear time subarray optimization. Now you have learned to stop brute forcing your way through problems and start thinking like an engineer. In the next lecture, we are going to dive deep into memory management. If you find value in this session, please hit that like button. It supports the channel. And make sure to subscribe to Techmine Guru for the complete journey. I am Supratim, signing off for today. Keep learning, keep coding, keep optimizing.